Welcome to the Introduction to Femap video series. In the previous video, we set up the material and element properties on the machined arm component and defined loads and boundary conditions. In this video, we'll continue the simulation process and mesh the geometry to create the finite element model. Then we'll set up the analysis parameters using Femap's Analysis Set Manager. With the model definition complete, we can then submit the job to be run using the NX-Nastran solver from within Femap. Femap has robust tools for mesh sizing and meshing. In addition to manually creating nodes and elements, you can extrude, revolve, and sweep meshes, and you have full control over mesh sizing for geometry meshing. Femap's meshing toolbox has powerful tools for editing geometry and meshes. In this example, we'll simply create a tet mesh on the arm. Expand the geometry object in the Model Info pane. Right-click the solid arm and select Tet Mesh from the menu. At this point, you can either mesh the part or change mesh parameters and/or mesh sizing. Let's take a look at the mesh sizes for the arm. You can define a different mesh size, and in this case we'll increase the mesh size slightly to 2.5. We'll increase the number of elements around curves by lowering the max angle tolerance to 15, and deselect options for max size of small feature and suppress short edges. Details on mesh sizing and editing are covered in other videos. Click OK to set the mesh size and OK again to mesh the arm. You'll see information about the resulting mesh in the Messages pane. We'll clean up the display by toggling off Geometry and Nodes, and by selecting the meshing icon, the meshing toolbox becomes visible. You can click on the quality icon to visualize the quality of the mesh. Also, expanding the quality tool displays the maximum value of the Jacobian, the comparison of the actual element shape to the ideal element shape for the element type. Before we analyze the model, let's change the color of the mesh to make visualization easier. On the View toolbar, select the View Style pull-down icon and select the Color with Property Colors command. Since the property color of the aluminum material is the same as the color of the elements, right-click the aluminum property in the Model Info pane and select Color. We'll change the color to a medium green. Now right-click Analyses and select Manage. In the Analysis Set Manager dialog box, click the New button to create an analysis set. Since we're going to perform a linear statics analysis using NX-Nastran, the same as the preference setting for this particular Femap installation, we only need to enter a descriptive title for the analysis set. Once the analysis set is created, we'll expand the analysis set to view the master request and conditions tree along with its boundary conditions subtree. Femap has automatically assigned the load and constraint sets that we created in the prior steps as the constraints and loads for this analysis. By clicking the Analyze button, an NX-Nastran input deck is generated for this analysis, and the analysis monitor is automatically opened. This monitor displays relevant information about the current running analysis, and you have the option to change the display of the progress of the analysis to different sets of information. Once the analysis is completed, the results are automatically added to the Femap model, and you can close the analysis monitor at this point. In the next video, we'll move on and view analysis results in Femap and make use of some of the post-processing tools and the post-processing toolbox. Don't forget that in Femap's help system, you have access to a number of worked examples that you can step through, and there is a link to the Femap community where you can network with other Femap users and pose questions. There are also numerous other videos available that demonstrate Femap's capabilities, and these are available on the Femap website under Femap Videos. To reach this page and for further information about Femap, visit siemens.com/plm/Femap.